This is question 3 from tutorial 2 from LO1 course notes, which you'll find on page 14 of those notes. So this is an example of a question where you use the graphical method in order to find the resultant vector. In this particular question, we have two vectors which have been given, and one is 15 newtons. It's acting 75 degrees up from the positive direction of the horizontal, and we've got a 30 Newton vector acting along the positive direction of the horizontal. Now, the usual in my videos, I'm going to colour in the vectors red and blue. We use these two colours to indicate two of them, and that's just so that you can see when I do the diagram joining the vectors together, how I've come about it, where these come from on our free body diagram. Now, if we're looking at this on a piece of paper, we want to create a scale. And so I would say if I've got a 15 Newton vector and a 30 Newton vector, maybe a scale of something like 1 centimetre to 3 newtons might be a sensible scale. So I would write that out. You could do 1 centimetre to 2 newtons as well. I mean, these would all fit on a piece of paper, but pick something sensible. And I'll mark this scale out on my page just to have a reference as well about how big this is. So what I'm saying is, I call these little intervals 1 centimetre on the virtual ruler, because the next best thing. I'll call that 1 centimetre there. And that's 3 newtons. So I can begin by drawing either of my vectors to scale pointing in the appropriate direction. So I think this time I often start at the top and work my way around, but this time, just to demonstrate the question be solved in either direction, I'll start off with the blue vector. So that's pointing along the horizontal line. I know the next vector is going to be up the way, so I want to start somewhere lower down my screen. And I'm going to draw this on in blue to show the same vectors on the diagram. And I want to mark off 10 intervals, because I said every interval is 3 newtons. So 2, 4, 6, 8, 10. So that line represents 30 newtons in size, and the direction is the same as our vector. And I'll put an arrowhead in that as well and mark off 30 newtons. Now, we're told in the question that our red vector is angled upwards from the horizontal at 75 degrees. I'm going to extend the horizontal line here, so the dotted line, so I've got something to measure from. Now, as ever, you'd be using your protractor for this to measure an angle of 75 between this dotted line and where our ruler is going to be. But I don't have that on the screen, so I'm just rotating around 75 degrees from my line there. I'm lining up the beginning of an interval with the end of the blue vector, and I'm going to draw a line that is 5 intervals long, because if you remember, an interval represents 3 newtons, so this could be 5 centimetres on your paper. 1, 2, 3, 4, 5. And again, I'll draw an arrowhead here to represent the direction it's going in. That's very important. I'll mark on the size, and I'll also mark in this angle here of 75 degrees. There. Now, to conclude, as with any other time, we're going from our starting point, which, if we remember, was here, to our ending point of the path of vectors. Now, no matter how many vectors we draw, we go from the start of the first one to the end of the last one. So I'm going to get the ruler and draw a line between the two of them. Now, I'm not going to worry too much about the angle just now. I'll see what that is in a second, but you'll be able to see it in the screen. But I'm just going to try and get something that's a reasonably good match for the two ends. I think this is not too bad. I just want to touch the beginning of the blue and the end of the red one. So I will draw a line up here. And remember, this is pointing from our start to our end. So put it away for a second. So that arrow joins up like so here. Now, I suppose we should probably just measure the angle since it's pretty apparent. The angle between the horizontal and this line is 23 degrees, so I'd want to mark in 23 degrees here, any circumstance. You'd probably be doing this the other way around, though. You'd be measuring the line first. I'm going to measure the line and do my best to give an approximation of what it is. And if I start at the bottom and match an interval onto the left-hand side of the line, I can count up 2, 4, 6, 8, 10, 12 and a quarter roughly. It's very approximate in this, but 12 and a quarter intervals is going to be, if we multiply that by 3, be 36.75. So I call that 12 and a quarter centimeters, if you like. That's going to equal 36.75 newtons. Now, I'm sure you can get much better accuracy on your own drawing, but that's not too bad for here. So I would be saying my answer here for the resultant vector. So resultant vector, and I would be saying its size 36.75 newtons. I might not give it that accurate. I might have just said 36.8 or 37, but we'll go with this. And the direction, well, we could say it's 23 degrees above the positive direction of the horizontal, or I can just draw something like this, just to make it clear what our direction is. So that's showing that the vector is 23 degrees above the horizontal line. If you compare that to the answers in the course notes, you see it's not too bad. The answers are 36.4 newtons and 23.5 degrees. Remember, these are calculated values. You'd never be expected to give anything more accurate than the nearest degree in the question that you're doing here. So that concludes this question 3 from tutorial 2 in the LO1 course notes.